right, let's go ahead and look at another hypothesis test. Researchers analyzed data compiled by a national hospital survey which tracked mental health visits to hospital emergency departments over 10 years. Out of 3,231 psychiatric patients, 642 were admitted to the hospital, compared with 825 out of 5,896 of the medical patients. Were psychiatric patients admitted to the hospital at a higher rate than medical patients, and what can you conclude at the 5% significance level? This is p hat. In other words, it's out of. That's the key word. When you have out of, we're looking at proportions. P hat 1 is 642 out of 3,231. P hat 2 is 825 out of 5,896. So plugging that into my calculator, I get 0.199 and 0.140. Let's set up the null and the alternative hypothesis. The null hypothesis is that the two proportions are the same, that they're admitted at the same rate. In other words, the proportion of psychiatric patients and the proportion of psychiatric patients were admitted, psychiatric patients, the proportion of medical patients were admitted at the same rate. So that's P1 equals P2. The alternative is at a higher rate. So this is, notice, we took off the hats, the P hats, because this is not for a sample, this is for a population. Is this true for the population of medical patients versus psychiatric patients? All right, so alpha is 5%. We are looking at a z-test because this is a test on proportions. Proportions is always a z-test. Set up my normal curve. I'm going to put one standard deviation away from the mean. The null is that the two proportions are the same, P1 equals P2. That would mean the difference between them is 0. That's really what I'm testing, is there a difference? And so I'm going to assume that there is a 0 difference between them. The standard deviation of the difference between these proportions is a little tricky. We don't know the populations. They weren't given to us. We don't know the population proportion. Therefore, we need to use, so we can't just do P minus 1 minus P times Q over N or something like that. We need to use the pooled estimate. So that's what this stands for. This is pooled estimate times 1 minus the pooled estimate times the square root of 1 over N1 plus 1 over N2. The pooled estimate is like, what's the total proportion of people who get admitted? That's the 642 plus the 825 out of the total number of people. So this is approximately 0.161. I plug that into my formula, and I get that our standard deviation is 0.008. So what that means is that about 68% of my samples that I get will have a little less than a 1% difference. All right, we obviously have more than a 1% difference in our samples. In fact, our sample difference is 0.059 or 5.9%, almost 6% difference. That's obviously way out there. I want to know, what's my test statistic? Here's my formula for my test statistic, and I plug all of my numbers in, and I get approximately 7.33. That's a big z-value. I'm probably going to reject the null, but I'll still go ahead and find my critical values. My critical values comes from alpha, and if this is a one-tailed test. This is a 5% significance level, alpha, and it's a right-tailed test. That's 5% in the right tail. I can do inverse norm of 0.95, area left, and I get my critical value is 1.645. As I figured, my test statistic lies in the critical region. It's really big. Therefore, I'm going to reject the null. What that means is there is sufficient evidence to show that psychiatric patients are admitted at a higher rate than medical patients. So we're done with the test. I mean, we've already concluded that yes, psychiatric patients are admitted at a higher rate. The reasons for that we won't go into. This test just is concluding that they are admitted at a higher rate. But I want to show you the different method, just called the p-value method. The p-value method, I want to set up my normal curve again. I want to find the area, the extreme area from my test statistic, which is 7.33. Because this is a right-tailed test, I'm just going to find 1 times my area to the right of this. I can do this using a normal curve calculator. Just find the area to the right of 7.33, and it shoots back, that's approximately 0. Or I can, better even, I can do a 2-prop z-test where I enter in x1, n1, x2, N2, and then I tell that it's a right-tailed test. It gives me my test statistics, 7.31, which is slightly different than 7.33. That's just due to rounding from when I did it by hand. The p-value is 1.336 times 10 to the negative 13th. That's 12 zeros, and then 1336. Let's call that about 0. There's almost a 0% probability that if these were the same that I would get a sample so different. So we're rejecting the null. We're saying, yes, they were admitted at a higher rate.